Shall we start? Can you hear me? Yeah. Can you hear me properly? Yeah. Have you all uh, turned in your homeworks? Last time some homework was there. I'm sorry. I mean, I haven't been able to. Okay. Sankalpa, I will check it. Anyways, before that, only Sankalpa has given or others also because Atharva, Samir, Suraj, half. Only half you've done. Why don't you done? Okay. So have you submitted it into the class? Actually, I'm into the class. So I'll yes. Okay, fine. Fine. I'll just check it later. Initially, let us start with the classwork, ma'am. In Google Classroom, no homework was assigned. Okay. But I had told it. Even I was new to the whole thing because that was my first class with you people. So then I requested madam to add me to the Google Classroom. Okay, fine. So what we'll do is that exactly I'll reassign it into the but how to turn in the okay, fine. So let's do one thing. I'll put it, I mean, I'll do the screenshots and I'll put it into the Google Classroom again. Okay. Then maybe you all can resubmit or turn in the homework. Will that be fine? You all also there into the Google Classroom, right? All of you. Anyway, okay, fine. So we'll do that again. Plus, we'll do see what activities are there in today's class, and those also we can do so that together you all can turn in the homework. Okay. Even I missed it. I have also need to. I mean, I should have put it into the Google Classroom. So maybe I'll do that today itself. So then by next class, I'll give a due date also when to, so that even I'll be checking it and we can proceed that way. Anyways, let me do the presentation for today. Now, last time's things they were clear to you all. We'll do a quick revision of what we did last time. Huh? Yeah, you have some doubts in bond line. Yes, what are the doubts, Sankalpa? Tell me. So that when I go there, we can. What is your doubt? Just put into the chat box. Is my screen seen? Is my screen visible? Yeah, this was it. Basic principles of organic chemistry. Yeah. Okay. Fine. Ma'am, if there is a double bond in the structure, then can we show it anywhere in the bond line? Yes, you can show it in the bond line. Say, for example, let us have a structure of propene. Fine. Double bond. Okay, I'm talking about. So even you can show a triple bond also. Just need to show it the way you're showing the single bond. Let me just go back. What happened? Yeah, this is the bond line structure, right? We are talking about. So before that, supposing this structure I need to put in CH3 CH double bond CH CH3 butane. Okay, or and another structure is also like this, same, but I am showing with a triple bond. Huh? This is a triple bond C CH3. So how do I put this in your line structure? CH3 CH. Let me do it this way. Undo CH. Then you have these double bond CH and same structure CH3 triple bond and CH. And then if you have some further this, then you can say, for example, you have a big structure CH3 CH double bond CH CH2 C. Let us see if we can put this. Okay, so this is your first CH3, then you have CH, this, then you have a double bond for that, then a single bond, then CH2, oh sorry, so CH3, CH, CH, CH2, then you have C, then you have triple bond, this, then CH2 and CH3. Is it clear? Could you see that, Sankalpa? Okay. In fact, it's very easy to do it. Okay. So you just, when you put in a double bond, it is understood that the number of hydrogen atoms are less over there. Okay. Fine. Let us go further for that. Okay. So now here, we said that carbon chemistry or carbon is able to form many compounds. Okay, simplest one is methane, and then to a more complex such as DNA molecule with many carbon atoms in it. Then we also saw, so there are many complex structure also possible. That is organic chemistry is a branch wherein you have so many compounds wherein carbon can form, and then the pharmaceutical industry, drugs, dyes, the industry, textile industry, all these have very complex structure wherein carbon is involved. Now, therefore, we will be studying this organic compound as a very interesting. That's what we said. Then I gave you this as a homework. Okay, before that, we just talked about why is it possible. Then we said that you said that it has double bond, triple bond ability, formation of double bond, triple bond ability of carbon. Also, the process of catenation, that is forming of chains. Then we said, I told you to find out the structure of glucose. This I put it again so you can turn in your homework. Camphor and paracetamol. This is what I had told you. This was supposed to be a homework if you remember that. Okay. Assign the hybridization state. You said you all don't know. Okay, fine. That is coming later on. We'll talk about that. Then next was what? This also, try the structural formula of ethane, then draw electron dot structure. We saw that the electron dot or Lewis structure. In the previous standard, you learned how to write the structural formula, molecular formula, and electron dot structure. So this was it. So we put in the structural formula, then we decided or we learned how to go for Lewis dot structure or your electron dot formula. Okay, Lewis formula, which is called as electron dot structure, also called as Lewis structure. I told you that you can put in a cross also instead of dot for the other electron, other element. Says hydrogen, you can show it as a cross, and carbon, you can show it as a dot also, dot cross, dot and cross. Then next we went on to talk about condensed formula. You told me that there was we can go to the molecular formula also. So this is it. And then from here we talked about the zigzag line formula. Just now what we did, that if you have different compounds, you can show it with this line. The heteroatom carbon and hydrogen is represented by the line. So the intersection of the line denotes carbon. And then we talked about that if there is a heteroatom, you can put that also. Okay. So this was another homework which you had to do it. So we'll do it that. I'll also put it. See here it is. Here see there is a double bond which is shown. So you have to show that structure over here. Okay. Here you have a triple bond also. Just now as I showed, you can show it over here. Drawing the molecules in three-dimensional structure. Then we started or we talked about how to show a three-dimensional structure. So we had, I think we had come over here if I remember correctly. I had shown you the model for today also some Newman projection formula and all. We'll look into the model for those. Okay. Now drawing the molecules in three dimension. Most organic. Okay. Can we discuss about last structural chart? Which one? No, I was asking about where to place it. Madam, if there is a double bond in the structure, then can we show it anywhere in the bond line? How can that be possible? You can't show it anywhere in the bond line. Now, just now I showed you. Was it clear, Sankalpa, then? Just now what I showed you, have I answered your question? Okay, fine. Alright. Now Suraj is saying, can we discuss about last structure in the chart, how it is formed? Uh, One moment. Let me go back to that chart. Okay. This structure. Okay, fine. Let us talk about that. Okay. This structure. So you have CN, you need to write. Then you have after that CH, OH, and CN. Okay. Now since there are two CNs over here, you can as well put it as CN twice and CHOH. Okay. That can be also done. This is for condensed formula. Then condensed formula B, this is your condensed formula A, and this could be a condensed formula B. So this is your condensed formula A, and this is your condensed formula B. Am I right? Okay. Is that, who was it? Suraj? Is that okay? I mean, are you following it? That this is how you can write it? One minute, let me go back. Fine. Now about the um, this diagram. What was it? Our zigzag line. Fine, let us go to that. If we have to show this in a zigzag line form, let me just clear this. Okay. The structure was, this was your structure, CN. This was your condensed formula 1, which I'm talking about, CHOH. Condensed formula 2, we can write it as CN, CHOH, and CN again. Okay. Fine. And then we have to show it with zigzag line. So first you have 1, 2, and 3. This carbon is there, so need not be shown. But you have a nitrogen over here, so show that nitrogen. Okay. Then CH. You have an OH over there, so you can show it as like this. And then you have C triple bond N. Okay, so if you try to, then this your OH. Oh, sorry. O. The bond should be on O properly. Show the bonds properly. Carbon, the valency should be seen properly. Always. So this is that C, this is your CHOH, and this is your CN. Is it clear? Don't show this. I have shown these C's just for you to understand it. Okay. So once again, if I have to do it, it will be, supposing this way I do that N down, then triple bonds, then you have this carbon, then you have OH, and then you have another carbon, and then you have triple bond. And okay, and you can O and H. So you can just roughly, you can inside you can put with pencil the carbon. Later on you can rub it just to check it whether you have taken care that all the 3 carbons are taken care of or not. Is it clear? Is that clear? Yes, only nitrogen and OH have to be shown. Yes, the heteroatom needs to be shown. If you remember, if we go back there and if we check it out, you can see that. So now you can do the homework properly. See here it is mentioned. Where was it? See, for example, propane is shown. However, the heteroatom, this line is important. Okay. Remember that. However, the heteroatoms or hydrogen atoms attached or bonded to heteroatoms are written clearly. This is how they have shown the alcohol. This is nothing but alcohol formula. So when you write it like this, OH, see this. So what does it tell you? That there is a CH3 over here and CH2 over here. And then you have an OH. So C2H5 OH can be written like this. Okay. Clear? Can we go further now? Yes. Okay, fine. Now let us talk about the other ways how you can represent it. That is your wedge formula. The three-dimensional structure or 3D view of a molecular formula can be presented on the plane of paper by representing the single bond using solid wedge, dash wedge, and normal lines. A solid wedge is used to represent a bond projecting up from the paper towards the reader. Okay, a dash wedge is used to represent a bond going backwards, that is below the plane away from the reader, and normal line tells that it is in the plane of the paper. Okay, so here how it is being represented is can be replaced by solid, bold and dashed lines. For convenience, solid and dashed wedges. This can be represented by a dash line also. So what do they mean by this? See, supposing normally methane structure, okay? I'm just putting it as a methane structures. So when I want to put methane, we show it like this. Say for example, this, 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 and this. Okay. In that you put in C, sorry, carbon, hydrogen, 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 and hydrogen. Fine. But we say methane has got a geometry, that is, it has got a tetrahedral geometry. Now, before I go further, I want to, last time I had shown you the structure, same thing I want to show you. So if you understand that properly, then only we can go further or you will understand it properly. Let me just go back to that. One moment. Huh? Okay, I'm just putting my camera on for 2 minutes. Okay, fine. Okay, just have a look at this. This is the structure. This is that methane structure. Now this has got a geometry, that is, supposing you can see that this is a central carbon atom. हा जो आहे तो central carbon atom आहे आणि हा जो bond आहे हा मला मागे आहे पण तुमच्याकडे प्रोजेक्ट करतोय. ओके, सेम थिंग यू विल बी सीइंग that there is one bond which is coming towards me, one is coming towards you. This is in the plane of the paper and this is coming towards me. This bond is coming towards me. ओके, हा दिस बॉन्ड आहे, हा जो बॉन्ड आहे तो माझ्याकडे. म्हणजे आता मला जर का हा ह्याच्यामध्ये दाखवायचं असेल, इफ देयर इज अ प्लेन, see, this is the plane of the book, and you can see that if I want to represent it in this plane, so you can see that there is something which is coming from the plane out, and then there is one, this can be imagined to be going inside the plane, and then there are two bonds which are into the in the plane of the paper. Can you imagine this? हे बघा, हा जो आहे तो पुढे येतोय, हा आणि हा ह्या प्लेन ऑफ पेपर मध्ये आहे, आणि जो मी धरलेला बॉन्ड आहे ना त्याला इमॅजिन करा की तो मागच्या साईडनी आतमध्ये येतोय, म्हणजे माझ्याकडे येतोय. हा जो आहे तो तुमच्याकडे येतोय. ओके, हा मला पाठमोर आहे. आर यू, कॅन यू इमॅजिन दिस? Can you imagine that? Okay. Yeah. Can you, now you can put it into, yes. So this is it. So this is the structure which I want to show you. Yeah. So here, consider that there is a plane here, invisible plane. That plane madhe, you can see that these two bonds are in the plane. Which one? This bond and this bond is in the plane. This bond is टुवर्ड्स यू, दिस बॉन्ड इज टुवर्ड्स मी. म्हणजे हा बॉन्ड जो आहे तो मला पाठी आहे पण तुम्हा लोकांना समोर येतोय, पुढे येतोय. ओके, तुमच्याकडे. आणि हा माझ्याकडे येतोय. ओके, so the bond which is not seen by me properly or which is behind the plane is shown by a dotted line, and the bond which is coming towards me, म्हणजे हा जो मी धरलेला बॉन्ड आहे, it is towards me, it is shown by thick line. आणि हा जो बॉन्ड आहे that is into the plane of the paper, it is just shown by normal lines. How we, okay, so let us try to represent that. Fine. So I am fine. Let us now go back and show it. So this was where. So when you're trying to show that, how will you show it? So always remember that first that carbon, you can show that carbon. I'm using a different color. So this is that carbon. Then I'm using this. This is one to show one hydrogen. This is the another hydrogen. Okay, now I want to show the dotted line. Let me see if I can do dotted line with this. Dotted line. Okay, okay, fine. Before that, this line. Then dotted line, let me show it this way so that it is going behind. It should be a straight line. Okay, and there is a thick line also. So that thick line, I'm just doing, oh sorry. Okay, so this is how you can show the, so this is in plane, this is one two dimensional. ह्याला काही हे नाही आहे, इथे आपल्याला कळत नाही कुठचा बॉन्ड मागे आहे कुठचा बॉन्ड पुढे येतोय. But the moment you draw like this, anybody in the world who knows chemistry, this is the language of chemistry, so they will immediately understand, okay fine, you mean to say that this particular bond is coming. आता हायड्रोजन सगळेच असल्यामुळे तुम्ही म्हणाल की ह्याच्यात काय दाखवायचं म्हणून, बट सपोजिंग हा हायड्रोजन नाही आहे, इथे काहीतरी वेगळा ॲटम आहे. से फॉर एक्झाम्पल यू टेक क्लोरीन. ओके, इथे आम्ही क्लोरीन घेतलं. इथे कुठचं तरी आणखीन एक दुसरा ॲटम घेतला. से फॉर एक्झाम्पल वी टेक हिअर ब्रोमीन. So when I show it like this, any person who knows the language of chemistry will say, okay, fine, which means these two bonds are in plane of paper. This bond bromine is away from me or observer, and this bond chlorine is towards the observer. Fine. So this is the fun in putting in this, which is called as wedge dot formula, wedge dot or dash formula. Why wedge? This is called as wedge. This is a wedge line. Okay, this is the dash or dotted line, so wedge dot. Okay, dash line, and this is the normal line. Okay, so that is what is in the that formula. Is it clear to you all? Have you understood? Because in the exam they can ask you write down wedge dot formula for any given compound. Fine. So then you should understand that this is how it is to be written. So now you can say this is the wedge formula. You can see that these are the bonds which are in the plane of the paper. हे जे आहेत ते दोन. This bond going below or which is going behind the plane of the paper. So I will not be able to see it. Whereas this is the bond which is coming towards me. Okay. So this is the bond in the plane of the paper. So this is the language of chemistry wherein you can represent the three-dimensional structure. Now, another thing is Fisher projection formula or cross formula. In this representation, a three-dimensional molecule is projected on the plane of the paper. Okay, even this is used to represent a three-dimensional element. A Fisher projection formula can be drawn by visualizing the molecule with its main carbon chain vertical. It is like this, okay? Each carbon on the vertical chain is represented by a cross. So this is like, say for example, by a cross. The convention is that the horizontal lines of the cross represent bonds projecting up from the carbon and vertical line represent bonds going below the carbon. Say for example this. Now, okay, if we represent this is the wedge formula. Okay, I'll just go back. Okay, now tell me, supposing I show this structure. C. Okay, C. Then you have OH. Then you have, no, let me just put in COH. COOH. Another one, CH3. Then you have a solid wedge. Okay. Then here you have OH and here you have Br. Now I want an answer from you from the wedge formula. What do you understand? Just answer my question. The dotted line, tell me what do the dotted lines tell me from the wedge formula? Just now what you learned. Don't look into the book what they're saying. Just now what I have shown, tell me. The dotted line tell you what? Which were the groups on the dotted line? Yeah, they are below the plane. That is, they are behind or below the plane. Fine, very good. Means COH and CH3 are behind the observer. And what about BR and your where is it? Yeah, OH. What does BR and OH tell us? They are above. That is, they are towards us. Okay. असं imagine करा की आपल्या समोर आणि आपल्या पाठीमागे. Okay. व्हेरी गुड, व्हेरी गुड. आता हेच जर मला फिशर प्रोजेक्शन मध्ये, आणि एक लक्षात ठेवा, फिशर प्रोजेक्शन इज नॉट यूज टू शो एनी कंपाऊंड. फिशर प्रोजेक्शन इज ऑलवेज यूज टू शो कायरल कंपाऊंड. कायरल किंवा चिराल किंवा आय टेल यू व्हॉट आर कायरल कंपाऊंड. फॉर एक्झाम्पल, या ह्याच्यामध्ये what is the difference between, fine, what is the difference between this structure H, H. All these formulas were used to show not normal color. This is, yeah. What is the difference between this and this structure? Just tell me before I go further. I want you to understand. What was the difference between methane and the structure shown by me? What is it? Ek minute. What did you write? We can't know the actual 3D structure in figure 1. No, that is okay. Forget about figure, about the 3D structure. I'm not saying yes, you're right. But look at the groups. Look at the groups there. I'm interested more. I mean, my question to you is with respect to, can you see that this is a different group, this is a different group, this is a different group, and you have another group which is different. What about this? Here all are same. Okay, so Fisher projection formula, have you noticed that? My question is, the point of wedge line towards carbon is away. What thin point of wedge line towards carbon or away is there? Here, there, yes, there is some convention, but right now you don't bother about that. Suraj, good question, but for you, only put it as dash also will do. It is something like, opposite. That I'll tell you next time. When right now, let us go slowly. First, you understand only that it should be, you can put it as only a simple dotted line. You don't have to show that which end. Normally, the thin point comes from the carbon towards the group. Okay. And when you to show the opposite, I mean the other, that's what I'm trying to tell you. It is used to represent the stereochemistry. That is a three-dimensional arrangement of a carbon which is having all four groups different. Okay, so therefore that time it is used. But right now you just don't bother. If there are functional groups in the structure you drew earlier, and the second figure is pure hydrocarbon. Yes, Sankar. But understand that we show these, that is the wedge formula, the Fisher projection formula, all these formula are used to show a carbon with all the groups, four groups different. So therefore, that's what I want you to understand. So in this case, this is wherein here you can see all the four groups are different. So now let us go to use. So Fisher projection is used in case of such compounds that wherein all the four groups are different. Now when you're putting in Fisher projection formula, the vertical line will be using for the groups which are behind, and horizontal line is used to show groups which are above the plane of the paper, which are below the plane, and those which are. So now which groups are behind? So let us see that your COOH, so this is your COH, which is behind, and then you have OH over here, then you have Br over here, and then you have CH3 over here. Okay, I can never show this formula. I mean, I can, but this is not a correct method to show this formula. Reason is, here you show the chiral carbon atom. This carbon atom is called as asymmetric carbon or chiral carbons, and it is always represented by a star. That all the four groups where they are different is called as a chiral, but you don't write it. Again, this is also, in this case, you don't show that chiral carbon atom. The intersection of those lines will be uh, representing the carbon as the chiral carbon atom, where the lines meet or the intersection. Are you following what I'm trying to tell you? कळतंय सगळ्यांना तुम्हाला की कन्फ्युजन आहे? कळतंय ना? ओके. सुरुवातीला आपण वेज डॉट फॉर्म्युला, एक लक्षात ठेवा, वेज डॉट फॉर्म्युला रिप्रेझेंट केला. वेज फॉर्म्युला हा केव्हा यूज करतात? 3 डायमेन्शनल स्ट्रक्चर दाखवायचं. जसं मी आता तुम्हाला जे स्ट्रक्चर दाखवलं, ज्याच्यामध्ये कार्बन जो आहे तो काही म्हणजे कुठचा पुढचा कार्बन आहे, कुठचा मागचा कार्बन आहे, असं जेव्हा दाखवायचं असतं त्यावेळेला. एकदा वेज फॉर्म्युला दाखवल्यानंतर आता आपण वळलोय फिशर फॉर्म्युलाकडे. फिशर फॉर्म्युलाकडे तुम्ही केव्हा येता? ज्या वेळेला तुम्हाला चारही कार्बनचे ग्रुप्स, चारही बॉन्ड्स आहेत हे वेगळ्या ग्रुप्सना अटॅच झालेले आहेत. म्हणजे समजा सगळेच ग्रुप सारखे असतील तर त्यावेळेला तुम्ही फिशर प्रोजेक्शन फॉर्म्युला यूज करू शकत नाही, हे एक लक्षात घ्या. त्यामुळे तुम्ही पुस्तकात जेव्हा ती एक्झाम्पल्स बघाल, की त्यांनी जे दिलेले उदाहरणं बघाल, त्यावेळेला तुमच्या लक्षात येईल की जे बॉन्ड्स म्हणजे ग्रुप्स अटॅच केलेले आहेत ते चारही ग्रुप्स वेगवेगळे आहेत. असं म्हणजे मुद्दामून केलेले त्यांनी, कारण त्यालाच तुम्ही फिशर प्रोजेक्शन, सगळ्या गोष्टी कार्बनच्या सगळे स्ट्रक्चर्स आपण फिशर प्रोजेक्शन मध्ये दाखवू शकत नाही, हे मला तुम्हाला लक्षात आणून द्यायचं आहे. ओके, सो वन मोमेंट, आय थिंक आय okay, so that was it, and let me go back. So this is it. Now you can see that, where is it? Fisher projection. In this, Ata will read this so that you'll understand. In this representation, a 3-dimensional molecule is projected on the plane of the paper. A Fisher formula can be drawn by visualizing the molecule with the main carbon chain vertical. Okay, we don't do a horizontal, वरनं खाली येते नेहमी. Each carbon on the vertical chain is represented by a cross. So this cross, you can see here also the groups are different. In this case as well, you can see that all the 4 groups are different. This is a different, this is different, this is different, and this is different. They have purposely taken this as example wherein all the 4 groups are different. Now you can see that here this group is above the plane and this group is behind the plane or below the plane. So each carbon on the vertical chain is represented by such a carbon wherein all the 4 groups are different is a chiral carbon. Okay, and this carbon can be represented by a Fisher formula. The convention is that the horizontal lines of the cross represent the bonds projecting up. So these are the horizontal lines. So this will tell us that the bonds which are coming towards us, and the vertical line will tell us that the bonds which are going below or away from the observer. Similarly, you can see that there is another example which is being taken here. This is the Fisher projection of cross, and each cross at this point of over here, म्हणजे हा जो point आहे, this point is the carbon. So this carbon is here at this point. This carbon is here. So you don't need to show the carbon there. It is understood that and this is how it is represented. Fisher projection formula is more commonly used in carbohydrate chemistry, wherein you have carbons which are chiral carbon atom. Okay, that is all the groups which are attached to the carbon are different. Am I clear over here? कळलं का तुम्हाला? We'll take one more example wherein I will just put in so that you just tell me which groups are to be represented on the horizontal line and which groups are to be represented on the vertical line. I'm putting one structure over there, two carbon. In second example, two atoms are same. Which one? Second example, two atoms are same. Yeah, but correct. The two atoms are same, but you can see that you can see that for this carbon, four groups are different. This is one group, this is one group, this is one group, and this whole is group for this carbon. Same thing if you're looking at, look at the other carbon. Now, if you have to look at the other carbon, this is the other carbon. For that, you can see this is different, this is different, this is different, and this is also a different. Okay, so that is how each carbon you have to see. You don't have to see the groups in it, but you have to see the each carbon should be attached to different group. Are you following it? What I mean to say? Clear झालं का है? Suraj, have you understood? Okay, different atoms for a particular, very true. Yes, different atoms for a particular. Now let us do one more example and then we go for the next one. Fine, let me do one. So I'm just putting this. Forget it, I'm not doing all that. हे गरज नाही आहे, मी फक्त डॉटेड दाखवते. कारण त्याच्यात ना वेळ जाईल जास्त. Here, then I need to show carbon, another carbon, carbon, and then another dotted line. Okay, then I'm showing thick wedge. Okay, another wedge. This also wedge. This also wedge. Okay, now here I am putting in COOH. Here I am putting CHO. Okay, here I am putting Br. Here I am putting H. I'm putting all different groups, NH2, and you have H over here. Fine. Now tell me, if I have to represent that into the Fisher projection formula, just put into the box which will be on the vertical line and which will be on the horizontal line. This was the structure, which is going to be on the vertical line. So let me put this. First, let me do the lines, at least this and this. Okay, now tell me which groups are going to be on the COH and C. Okay, CHO. Very good, vertical line. And then the remaining are going to be on the horizontal line, right? So let us put that. Okay, so this was it. Hey, C. This was C O O H, and I have C. Look at the way I'm putting the bonds. That is also technically correct. कार्बनला कार्बन दाखवते, ऑक्सिजन म्हणजे मी आता काढते वेळी कसं स्ट्रक्चर काढते हे पण लक्षात घ्या. सी दॅट ऑल्सो रिफ्लेक्ट्स दॅट, नाही तर मार्क जाऊ शकतात. से फॉर एक्झाम्पल मी मुद्दामून हे खोडलं कारण मी असं काढलेलं नाहीये स्ट्रक्चर COOH. अंडरस्टँड दॅट आय हॅव शोन द बॉन्ड ऑन द कार्बन ओनली. ओके, असं काढलं स्ट्रक्चर तर जरी तुम्ही काढलं ते तरी मार्क जातील, because you're supposed to be showing your bonds on carbon only. So let me just put it as C, carbon should be shown, COOH. Okay, fine. Next was Br, so I'm putting Br, then you have H, then you have NH2. Now look at this, why I'm writing like this. NH2 मी असं का नाही लिहित आहे, for example मी असं लिहित नाहीये NH2, अंडरस्टँड दॅट बॉन्ड मी नायट्रोजनलाच दाखवलेला आहे. सो दॅट इज ऑल, अंडरस्टँड द वे आय एम रायटिंग इट. खरं NH2 आपण असं दाखवू शकतो, NH2 अँड असं, बट टेक्निकली यू शुड बी शोईंग इट लाईक दिस, वर इन कार्बन इज अटॅच टू नायट्रोजन. दिस इज व्हॉट इट इज. आणि हे जे इंटरसेक्शन लाईन्स जिथे होत आहेत, द क्रॉस दिस इज your carbon, this is another carbon, which is the chiral carbon atom. Have you understood it? Is it clear? Shall we go further? Yeah. Good. That is what I want. एकदा कळलं ना, डोक्यामध्ये फिक्स बसलं की कळवून घ्या. नुसतं रोट लर्निंग इज नॉट इम्पॉर्टंट. You understand, then anything, any structure will be easier for you. Okay, fine. See, now next is Newman projection formula. In this method, projection of a three-dimensional molecule on the plane of the paper is drawn by visualizing the molecule by looking through a CC single bond. In this case, the CC carbon-carbon is not visible. A convention is followed to represent the front carbon by a point. Okay, in this case, let me just come back to my structures. आता मी पुन्हा कॅमेरा ऑन करते. Okay, just pay attention to what I'm showing. I want to pin myself. Okay, fine. Just pay attention over here. Now imagine this structure. Hey, structure baga. Which structure is it? Can you put it into the chat box? हे कुठचं structure आहे? It's a light येतोय. Okay, which structure is this? Can you put in the chat box? Ethane, very correct. Ethane. I'm very happy. Why? Because you're understanding the structure. एक मिनिट, मला जरा क्लॅरिटी हवी आहे थोडी. Okay, it's fine. So this is ethane structure. Okay. Now आता आपण कसं केलं होतं, फिशर प्रोजेक्शन फॉर्म्युलाला असं धरलं होतं मॉलिक्यूल. अंडरस्टँड दॅट. इफ यू रिमेंबर, वी हॅड पुट द मॉलिक्यूल लाईक दिस फॉर युअर फिशर प्रोजेक्शन. म्हणजे जर का वही अशी बुक असेल तर त्याला आपण असं धरलं होतं. ओके, सो असं न धरता नाव यू आर लुकिंग इट दिस वे. म्हणजे see, there is the central carbon. This is ethane. I hope everybody you have put it. Yes, all of you have put it. This is one carbon, this is another carbon. This line which is joining is called as the central carbon bond. Okay, हा जो bond आहे, this is the central carbon. आता तुम्ही एक बघा, लक्ष द्या इथे. This is the front carbon, this is the front carbon, this is the back carbon. तर आता ह्या पोझिशन मध्ये न्यूमॅन प्रोजेक्शन, दिस इज कॉल्ड एज न्यूमॅन प्रोजेक्शन. ह्याच्यामध्ये फ्रंट कार्बन इज विजिबल, बॅक कार्बन इज नॉट विजिबल. कॅन यू, तुम्हाला सगळ्यांना दिसतंय? इज द बॅक कार्बन विजिबल टू यू? इज द बॅक कार्बन? हा, ओके. द बॅक कार्बन इज नॉट. तो फ्रंट कार्बन इज पुट ॲज अ पॉइंट. ओके, सो ज्या वेळेला तुम्हाला हे असं स्ट्रक्चर असेल, लेट मी जस्ट सी. सो अशा वेळेला the front carbon is shown as a point. Okay, so it is shown as a point, and the back carbon is shown as a circle. Even if it is not visible, it is, sorry, a proper circle. So let me just take the geometry. Shapes. Okay. Okay, this is it. So this is the back carbon. Before that, let me just put in the front carbon. Front carbon is shown as a dot over here. Okay, and the bonds which are coming out from the front carbon are shown as, so it is like this, and like this. Okay, and from the back carbon, understand that they are not going inside. Hey महत्वाचं आहे, they are not going inside, they are coming from the circumference. Okay, these are the three from here. Now ह्याच्यामध्ये ना various shapes आहेत. आता पुन्हा मी तसंच दाखवते तुम्हाला. हा, this is this, and then you have this, this, and this, and then you have this and this. आता ह्याच्यात मी काय आहे, दोन फॉर्म्स आहेत. वन मोमेंट, कुठे गेलं ते? Was it seen? You can understand. Okay. Was it seen what I drew just now? कळलं का मी तिथे चित्र काढलेलं दिसलं तुम्हाला? ओके, फाईन, गुड. तर आता तेच मला ह्याच्यामध्ये दाखवायचं आहे की हा जो कार्बन आहे, that is that this form is called as eclipse form. Eclipse form म्हणजे काय? ग्रहण. ग्रहण का म्हणतं? तर मागच्या, पुढच्याने मागच्याला झाकलंय. ओके, नाव द मोमेंट आय ओपन इट अप, यू कॅन सी दॅट. हा बघा, हा हिरव्या रंगाचा आहे, मुद्दामून मी वेगळा आहे. नाव दिस form is called as, this is called as conformations. These are called as conformations. CONFORMATION, conformation. हा ओपन झालाय. ह्याच्यामध्ये तुम्हाला सही बॉन्ड्स दिसतात. यू आर नॉट सीइंग द behind carbon atom, but you are able to see all the bonds over here, 3 bonds over here, right? So you can see the 6 atoms and you can see the 3 bonds over here. So this is called as staggered conformation. This is called as staggered conformation. Punha, if I rotate it, it is possible to go to the eclipse conformation. So therefore, see, eclipse नेहमी असं थोडं दाखवायचं, म्हणजे मागचे बॉन्ड्स पण आहेत पण ते झाकले गेलेले आहेत. Is everybody following? So ह्याच्यामध्ये दोन पॉसिबिलिटीज आहे. एक स्टॅगर्ड कन्फॉर्मेशन आहे आणि एक इक्लिप्स कन्फॉर्मेशन आहे. Front carbon atom is shown as a point, magcha carbon atom is shown as a circle, even if it is not visible. Do you understand that? Even if it is not visible, then but still it is shown as a circle. Bonds are shown coming from the front carbon atom, they come from the point. From the back carbon atom, they come from the circle. Okay, from the circumference of the circle, they are not joining inside. कळलंय का? They can ask you to show these structures: wedge formula, Fisher projection formula. Is it clear? Okay, fine. Let me just go back to the chapter. Fine. So here, see, in such cases, the CC carbon-carbon is not visible. A convention is followed to represent the front carbon by a point. Hai baga, ikde ha jo ahe. So this is a point. And the rear carbon by a circle. The remaining 3 bonds at each of these 2 carbons are drawn like spokes of a wheel. म्हणजे हे असे बाहेर येणारे, ज्याला आर्या म्हणतो ना आपण बहुतेक. आय होप आय हॅव यूज्ड द राईट वर्ड. स्पोक्स ऑफ अ व्हील म्हणजे चाकाच्या असे हे बाहेर येतात ना आरे. दॅट इज the remaining bonds at each of these 2 carbon are drawn as spokes of a wheel. Conventionally, 3 bonds at the front carbon are shown to radiate from the center. सेंटर मधला हा जो सेंटर आहे तिथून येतात बाहेर. बट यू कॅन सी दॅट हे जरा मोठं काढायला होता त्यांनी सर्कल. वेर ॲज the 3 bonds at the rear carbon are shown to radiate from the circumference of the circle. Figure 3, 4. This figure shows the 2 representation of ethane molecule by this method. Okay. आता पुढचा जो आहे, we have just 5 minutes. I just want to go. हे सेम आहे. Only thing is now, one moment, let me come back to you people. ओके ठीक आहे. आता इकडे जे आहे ते in this case what is done is this is Newman projection. आता sawhorse करताना you make an angle of 45 degrees. You understand that? So here look at this. The same thing आता मी फक्त थोडंसं फिरवलंय. ह्याच्यामुळे काय झालं आता सेंट्रल सीसी बॉन्ड आपल्याला दिसतोय. तर त्याच्यामुळे मी काय केलं आता दोन्ही हीच दोन स्ट्रक्चर्स आता मी पुन्हा एकदा पहिलं स्ट्रक्चर कोणतं आहे ते मला सांगा आणि दुसरं स्ट्रक्चर कोणतं आहे ते मला सांगा. ओके. Okay. Now structure A. Let me put this as structure A and this as structure B. Okay. ज्या वेळेला मी इथे actually this is HH. इथेन स्ट्रक्चर असल्यामुळे नाहीतर खरं ते CH3 आहे. आय एम सपोज टू बी पुटिंग H ओव्हर हिअर इफ यू रिमेंबर दॅट. जर का मी H नाही घातलं तर त्याचा अर्थ काय होतो देर इज यू हॅव CH3 over there. Actually, this was the structure of ethane. So I am just putting in all my hydrogen. तिकडे ग्रीन कलरचं हे होतं small. So this is H. Okay, fine. Now you tell me. Okay. Now tell me this the same structure. आता हे जे होतं स्ट्रक्चर एक हे आता मगाशी आपण ह्याला असं बघितलं होतं राईट. आता आपण बघूया तो एक we slowly turn it and make an angle of 45 degrees. When you make an angle of 45 degrees, this is called as sawhorse. आता इथे काय होतंय की तुम्हाला हा सेंट्रल बॉन्ड जो आहे तो तुम्हाला दिसतोय. You can see the central bond. So this central bond can be seen over here. Okay. So this central bond is seen because पहिल्यांदा न्यूमॅन मध्ये तुम्हाला तो दिसत नव्हता पण जेव्हा आपण सॉहॉर्स मध्ये बघितल्यानंतर आता हे जे प्रोजेक्शन आहे सॉहॉर्स मधलं दिस इज कॉल्ड ॲज युअर अगेन दिस इज युअर इक्लिप्स स्टॅगर्ड कन्फॉर्मेशन का कारण हा वरती बॉन्ड आलाय दिस म्हणजे जर का न्यूमॅन मध्ये बघितलं तर हे तुम्हाला इक्लिप्स दिसतंय स्टॅगर्ड दिसतंय तेच मी असं फिरवल्यामुळे हे सॉहॉर्स मधलं स्टॅगर्ड कन्फॉर्मेशन आहे ज्याच्यामध्ये तुम्हाला हे 3 बॉन्ड्स आणि हे 3 बॉन्ड्स हे ओपन अप झालेत. जर मला इक्लिप्स करायचं असेल तर न्यूमॅन मधलं मी हे इक्लिप्स असं आता हे जे आहे ते न्यूमॅन मधलं इक्लिप्स आले तर स्टॅगर्ड मध्ये तुम्हाला ते असं दिसेल. हे बघा हे 2 बॉन्ड्स आहेत हे 2 ग्रुप्स आहेत ह्याचे पण 2 ग्रुप्स आहेत ते वरती आहेत ते एकमेकांना झाकतात आणि हा जो खालचा सिंगल ग्रुप आहे ह्याचा पण खालचा सिंगल ग्रुप आहे. या स्ट्रक्चर ए इज इक्लिप्स. येस. Sankalpa, I haven't understood. B is what? B is IST म्हणजे काय madam? What if the 3 are 3 carbon atoms different? What if there are 3 carbon atoms? Yeah, for 3 carbon atoms it is little difficult. Normally for your syllabus it is not restricted to 2 carbon atoms only. So Newman 3 carbon atoms. You can show propane. I'll just show you. I'll answer your question. Okay, fine. Yes, first is eclipse and second is Sankalpa if there are 3 carbon atoms. Let us have that before we end. कुठे गेलं ते आता जर 3 कार्बन atoms असतील तर I can put here कुठे गेलं okay fine. Can I do it this way? See, this is my third carbon CH3. हे कसं झालंय इथेन स्ट्रक्चर होतं आतापर्यंत. सो दिस वॉज CH3 वॉज दिस. मग त्याच्याऐवजी आता हा एक H काढला आणि त्याच्याऐवजी तुम्ही टाकला दिस बिकम CH2 and then you have CH3. So this is it. So this is my front carbon atom. त्याच्या मागचा जो आहे back carbon atom. So this is the back carbon atom. With all this is front carbon atom which has CH2 and another H is being replaced by C. You can show 4 also. मागच्याला तुम्ही CH3 केलं तर 4 carbon atoms होईल. Are you following this? कुठे गेलं ते? Am I clear? Have I answered your question, Sankalpa? If there are 3 carbon atoms, okay, fine. So shall we? Yeah. So this was it. We can. Next time. Now it is. Next time I'll show you with the third carbon atom over here. I'll put a methyl group over here. Consider this as a methyl group only. CH3 वरती लागलाय. CH3. This is one CH3. This is one another one C and this one. So this is also a 3 carbon atom structure. You can imagine. We can do it next time. Or why next time? Here I have. Okay, look at this. See, this is it. Can you imagine this as a three carbon atom? This is your first carbon atom. This was my second carbon atom, and now this comes as a third carbon atom, CH3. Okay, fine. Look at this. So here now you have this as eclipsed. Okay, and when I open this up, this becomes staggered. Fine. Okay. So I'll put the homework in this. I will, if possible, I'll just see if I can put some structures and if you can put them, give me the Fisher projection formula and source. That also I try to put in. Okay. Chalo. Thank you. Good night.